Hi, it's Graeme Schwenke of Department of Primary Industries. I'm talking today about some recent research that I've been doing on nitrous oxide emissions reduction. Specifically, we've been looking at reducing emissions under dryland grain sorghum in northern New South Wales. The reason why we're looking at sorghum in northern New South Wales is because some previous work we did with other predominantly winter-based crops showed that the emissions from those crops were, while significant, quite a lot lower than what we found from the sorghum. So the sorghum, being a summer crop, has obviously a different growing season, and we're putting nitrogen in generally at sowing or even before sowing, and that nitrogen is highly subject to denitrification loss if the conditions become very wet between when that nitrogen's gone into the soil and when the crop uptake can start to use it, which is generally sort of after a month or so. So there's a key time there, and our research over the first 2 years has really backed that initial findings up, in that yes, that's really the crucial time. If you get very heavy rainfall and the soils become waterlogged, then the soils in our part of the world are cracking clay soils that drain very slowly, so that when they get a lot of rainfall, they can waterlog quite quickly and stay that way for a few days or more sometimes. And if there's a lot of nitrate in the soil from the fertiliser, with that heavy rainfall and waterlogging, that can lead to denitrification, and that happening in early summer when the conditions are quite warm, you can actually lose quite a lot of the nitrogen that's put on. Some of the figures that we found in initial mass balance testing, up to 50 kilos out of a 200 kilo application of nitrogen. So what are the ways that we're looking at in terms of trying to combat that or mitigate against that? Well, firstly, we're looking at getting the rate of nitrogen that's applied more tuned to what the plant actually needs, and not putting on too much or even too little. And we found, obviously, if you put on too much, then there's excess there, and that excess tends to be lost at a disproportionately high amount compared to if you had the optimum amount. So that was one of the first things we looked at, and then we looked at different ways of delaying the availability of that nitrate in the soil, so that we can still potentially put the fertiliser on at sowing, but if it's not turning to nitrate straight away, then we're not going to potentially lose that as denitrification. And one of the ways we looked at is using a nitrification inhibitor, which is a chemical name abbreviated to DMPP. It does cost more than the usual urea, but we found that it has between an 80 and 100% reduction in the nitrous oxide emissions. So if you do get those waterlogged conditions, then you're not losing that nitrogen. It's not becoming a problem for the environment in terms of greenhouse gas emissions, and you're not losing wholesale amounts as N2, which is the other product of denitrification. The other way we're looking at combating or mitigating this nitrous oxide emissions by delaying the availability of the nitrate is just a physical way of either splitting the application or delaying it. So not necessarily putting it all on at sowing, but saving some for a little later on in the growth. You can still get a lot of that nitrogen into yield, provided you get good in-season rainfall. And one other approach that we're just trying this season, so no results yet, is using a physical inhibitor of the urea applied at sowing, where urea is actually encapsulated in a polymer and only released in a slow release sort of fashion. So they're the approaches we're looking at, trying to reduce these emissions in grain sorghum.